The Burj Khalifa, Engineering the World's Tallest, by Corine, Ahmad, Aidan, and Matthew. What is it? The Burj Khalifa is a skyscraper in Dubai, in the United Arab Emirates. It is currently the tallest structure in the world and took 6 years to build. The building contains a large hotel, as well as office and retail space. It was originally planned to be entirely residential, however this created marketing issues. Some facts. It stands at 829.8 meters tall, or 2,722 feet. It cost a whopping 1.5 billion US dollars to construct. It is 163 stories tall. The labour force consisted of approximately 7,500 workers on site at a time, and at its full capacity, the building can hold around 30,000 people, 900 of which are permanent residents who stay in the hotel year-round. Some fun facts. At the peak of construction, 12,000 workers worked on the building per day. The total weight of aluminium used is equivalent to that of 5 A380 aircrafts. The weight of the concrete used is equivalent to 100,000 elephants. Amazingly, on February the 9th, 2015, the total area of the shadow cast by the tower was 3,600,000 square meters. Of course, as the Burj Khalifa is such a big structure, this created numerous problems that engineers had to overcome. One of such problems was created by the winds. Wind speeds towards the top of the tower can reach up to 80 kilometers an hour. Over 40 wind tunnel tests were conducted to try and replicate the conditions that would be present. Civil engineers spent months analysing the results, and along with architects, managed to come up with the Y-shaped plan. This structural system was described as the buttressed core. Each of the three wings buttressed by the others via hexagonal core. The result was that the tower was both stiff laterally and torsionally. This meant wind could strike the tower from any direction and the wings would remain unstressed, as can be seen in the pictures. More challenges arose with distributing power throughout the building. The building is 5 million square feet, so to find a way to effectively distribute the power was a unique challenge to ABB Electrical, who were the company tasked with doing this. A distribution substation, custom engineered for the building, sits on the 155th floor, which makes it the world's highest substation. This substation is absolutely vital to the functioning of the building, as it provides reliable, safe power to everything that runs, from lighting and elevators to the ventilation, heating, and air conditioning systems. The engineers had to find a way to fit appropriately powerful equipment into a relatively limited space. And as a way of tackling this, ABB delivered 50 lightweight, gas-insulated, medium-voltage switchgears, which offered a space-saving design, as can be seen in the picture. ABB also supplied 72 resibolic dry-type transformers, which were especially designed for the tower, with a flexible enclosure to allow them to fit into a very tight space. The stack effect. Another huge problem faced was the stack effect. This is the movement of air into and out of buildings. The warmer air is lighter and will rise to the top of the building, whereas the cooler air will try to fill the cracks at the bottom, as can be seen in the diagram. Now, this effect is prominent in all buildings and all structures. However, it was particularly problematic for a building of the Burj Khalifa's height, as the pressure created would be so great as it built up, it would be strong enough to crack the foundation, which would lead to structural failure. HVAC stands for heating, ventilation, and air conditioning. Engineers from this group consist of both mechanical and electrical engineers. They managed to come up with a complex air duct system which moved warm air out of the building. The physical air duct structures were then designed by civil engineers, and this minimized the stack effect. However, it's impossible to completely eliminate it. Another interesting problem posed was, as the building is over 150 stories tall, the elevators would need to be very quickly to get people around. There are a total of 57 double-deck elevators, which can each hold between 12 to 14 passengers, and 8 escalators. The elevators have a top speed of 10 meters per second, which makes them the fastest double-deck elevators in the world, and the overall third fastest elevators of any kind in the world. However, despite these long speeds, the wait time in the elevators was identified as a problem by the designers. The solution of this was to have electrical engineers implement entertainment features such as interactive LCD screens to keep passengers entertained, particularly during the ride up to the observatory, which is on the 163rd floor. So as you've seen so far, major projects such as this give rise to a plethora of problems, only a few of which we have outlined in the video. The solutions to these problems are often complex and require engineers from a myriad of different disciplines to help solve them. In the example of the Burj Khalifa, we can see such complications as the wind effect, electrical challenges, and the stack effect. A proper response to these quagmires requires, respectively, the disciplines of civil, electrical, and mechanical engineering. The elevators we mentioned previously in themselves are a fantastic example of an interdisciplinary engineering job where expertise in numerous fields is needed. Of course, a project of such magnitude definitely would have a big impact on society. So labour issues during the construction generated huge controversy for Dubai, as the building was mainly built by workers from South and East Asia. The reason for this is that the locals prefer to work in less dirty government jobs where they don't have to do as much physical labour. It's reported that labourers earned as little as 4.83 Canadian dollars per day and were subjected to abysmal working conditions and long hours in the 45-degree heat during the summers in Dubai. Only one construction death was officially reported. However, according to HRW, which is the Human Rights Watch, workplace injuries and fatalities in the UAE are poorly documented, so it is very likely that the death count would be much higher than this. Some more positive impacts on society. The hotel found in the tower employs over 600 staff, which creates job opportunities for the locals, as well as providing safer work opportunities for labourers who would otherwise be in dangerous jobs in the heat. And since opening, the tower has helped boost surrounding hotels and business revenue by up to 35%, as the tower acts as a tourist hotspot. The building has given Dubai international presence, which, as previously mentioned, creates a huge surge in tourism. This boosted the economy at a pivotal time during the financial crisis.